1 times 1.
No. That's not true. The square root of 2 is square root of 2 is 1.41.
Oh, 1 times 1.
Square root of 2 is 1.41.
And I don't understand. Well, no, because you're right here, but it's got to be a square root of 2, right? Well, no, the inside. Like,
So this
just
is
look at this. You have your square root, 0 plus 2. What's inside that square root? 0 plus 2. So you have 2. But you still have the square root.
Oh, like this.
Yes.
Okay.
Yeah. So now,
Okay.
what's your
So
square root of 2?
y equals the square root of 2 minus 3.
You know
Use-
you're gonna take
Use
square root of 2.
1.41 for the square root of 2.
Which
Is that right?
Square root of 2.
1.41?
Yeah, 1.41. Yeah.
It's been a while. Y equals
So
1.41 minus 3.
And then there, because the top one's inside.
Y equals negative
So the top
1.59.
one. If you ever need to use anything else. So then I'm putting 2. And enter. So 1.5
Oh,
So is this what folks got for the y-intercept?
minus 3.
Good?
So make
no, because I think I plus 3 on to get rid of that 3.
You don't have to. The y's already solved.
Square root of 2
Oh, yeah,
first,
that's good.
and then you just subtract it by 3. So 1.5
So you just keep it there, and then
No, you can do that.
then when you remove this, and then you take it away. Okay.
So the x-intercept, I think everybody got the x-intercept. That's when you set y equal to 0.
She used an extra significant number, so she used 1.41.
Yeah, if you use 1.4, that's fine. 1.4 is fine.
Yeah, so you could still
1.41 minus
say that
3.
within negative
Like it's
1.6. Yep.
Yeah, 1.6, negative 1.6 is totally fine.
3 equals, oh, negative 1.
Yeah, so all she did was get the square root of 2. So if you put in the calculator, the square root of 2, you get 1.4. And then from there, you get 1.4 minus 3, you just bring 1 by 3. And that's how she got the 1.55. No, because all the, so when you have a square root like this, really what it is like, you would know it's subtracted. If it was cubed, then you would multiply something 3 times to get what's inside of the square root.
So we have to square both sides. So for the x-intercept, y equals 0. Put in 0 for y. Add 3 to both sides, and then you have to square both sides. Right, you get your square root by itself. 3 squared is 9. And then what's the last step? Subtract 2 from both sides. And you get x is 7. So this is going to be 7 comma 0. So those are my 2 intercepts. So everybody, I feel like that's what everybody got from looking around.
Yeah.
Okay, great. So 0, we can do 1.6. We can do 1.6. That might be easier. Probably. So, was it 0? Negative 1.6. And 7 comma. I need to make a table, my bad. Alright, so here's my x and my y. 0, negative 1.670. Let's take a look at my function. What was my function again? My function was x plus 2 minus 3. X plus 2 inside minus 3. There's my function. So what are my transformations here? Everybody write down the transformations. Inside is what, up, down, or left, right? Left, right. Figure out where it's gone. Outside, that's my up, down. Figure out where that's transformed. When you're done, check with your neighbors. What are my transformations? Write down the transformations.
Oh, it in a form like.
Yeah, left or right or up and down.
Left to,
Brian, what's my transformation?
Left 2, down 3.
Great. Left 2, down 3. Then, you can just draw in your, in here, and you can mark off your points. My new center, my old center was here. Where's my new center? Go left 2, go down 3. Boom, there you have it. There's your first point. So what is that point? Left 2, -2, down 3, -3. And then, fill in your other 4 points. Everybody fill in the other 4 points once you have that first one. One's already filled in for you. So graph in the other, oh, no, it's a square root.
oh,
So it's a swish. This is a square root, it's a swish. Swish. Yeah. Okay, so from here, what are the other 4 points? Or was it
So
the
once,
negative?
so once we
Oh, that's
find
a
it,
negative.
we-
Oh, yeah, yeah,
I was
yeah.
trying to do 1 point.
I see, okay, that's fine, that's fine. Yeah, so
Okay.
yeah, that's fine. Then you do the over one, up one.
And then you still add.
Yeah, do these.
and
Do
then-
these other two then.
2, 4, and then what was it? It wasn't 9, 3.
Where's your other pen? New origin. Yeah, that's your new origin. So maybe put a little star on this one. Make a little an extra big circle to make sure that you realize that this is your new origin. The shift, your shift from 0, 0. This is your new center. That's the one that everything goes off of. It's the very first one in this section.
I was trying to see what the last point was. I forgot it because I got confused. I know that the cube was 9, 3, but the other one, 2 or something. 8, 2? No. The last one.
This one.
Oh, there it
This
is.
one.
Oh, yeah. Oh, 9, 3. Oh, that's the 8, 2, and 9, 3. I was getting confused. Okay, so 9, 3. So we go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2.
Yeah, that's this point. That's this point.
Oh, yeah, okay.
All right, so I think folks should have them at this point. From our new center, we go right 1, up 1. Also from our new center, we go right 4, up 2. And if you want to log in the 0, -1.6, that would be like kind of right around here. That's where that point is. These are the 2 points we found, our x and y intercepts. And then you draw your line. Oops, that wasn't a very good one. You draw your line connecting them. Good. Great. All right, so I want to find the range. Everybody find the range. What are the y's allowed to be? We already did the x's. Remember the x's we said was this stuff here. Right, that's our x's. Question is, what are our y's? What are the y's allowed to be? Looks like that sort of, right? Oh, let me undo that. Let me make that a little bit lighter. Right? for our range?
What?
So what's our range?
Parentheses or brackets, is it included?
What's the lowest it goes?
-3.
-3. What's the highest it goes?
3, 0.
Positive infinity, can it equal 3? Can it equal -3?
Yes.
Yes, so it becomes a square bracket.
Mm. So, stop it at 3. Wait, instead of that,
Yeah.
I thought it was a negative.
That's, no, for the range, the lowest it goes. What's the lowest it goes? That was our domain. Our domain was -2. Our range is the height, the up and down. Yeah. Okay, so, and then we're going to skip part 3.
Okay.
So C, the next page, we're going to skip this one. All right. Let's go ahead and take a look at, let's grab out our homework. And pause this for a minute. Help you folks with the homework that's due, was originally due on Monday, today, but I'm making it due on Friday. We're going to kind of go through rules of exponents. So the handout you should be looking at is is our homework. How many?
I think that's it. Unit 4, homework, simplifying radicals.
Yep, this one. We're going to take a look at this one right here. Alright. And we're going to do it using this one. Okay, great. So just as a reminder, multiplication rule, if they have the same base, you add their exponents. Right, so for example, 4 to the 5th times 4 to the 2nd, you just add their exponents, it's 4 to the 7th. Good. Everybody, this is just a reminder, refresher. And we know that because if I had, if I had x being multiplied 5 times, multiplied by x being multiplied by 2 more times, altogether it's x to the 7th, right? Here's 2 x's, this is x to the 5th times x to the 2nd, x to the 7th. Right? You have 7 of them being multiplied. Dividing, same thing, they have the same base. You subtract the bottom one from the top one. Right, because remember 4 to the 3rd on the bottom is the same thing as 4 to the -5 on top. Or sorry, -3 on top. Right, you can move this, we talked about like you can move this to the top and make the exponent negative. So 5 minus 3, -2. You subtract the ones on the bottom. Or you know what, you don't even think about it that way. You can do it like this because they cancel out. It's probably an easy way to kind of jump that. And this is, I'm going to use x's instead because they're easy to draw. 5 of them on top, you have 3 of them on the bottom. Right, and these x over x is just another form of 1, those go away. So you're left with 2 of them.
You just do 5 minus 3.
Yeah, 5 minus 3. That's what it is. Power to power, the exponents multiply. For example, x squared to the 3rd power means I'm doing this multiplied by itself 3 times. So x squared times itself 3 times. That's what this means. Where you multiply whatever's inside the parentheses by itself 3 times. So it's x squared times x squared times x squared. Altogether you have 6 of them. Right, so it's saying I need 2 x's 3 times, right? So 2 times 3. Altogether you have 6 of them. So, this is maybe the slide we missed before. What is x 16 to the 1/2? Well, by the rules, 16 to the 1/2 times 16 to the 1/2 is 16 to the 1. So what it is it's the number, it's the number that multiplied by itself gives you 16. Does that make sense? It's the same thing as this. It's also the same thing as that. Right? Because this says I multiply it by itself twice, I get 16.
Oh, so there's something missing on it, okay. This is what is 16 and a half? What you're
16 to
saying-
the 1/2. 16 to the 1/2 is this. They're the same thing. So it's the number that when I multiply by itself, I get 16. That's what 16 to the 1/2 means. It's the number that gets multiplied by itself twice to get me to 16. This is the number that multiplied by itself 3 times gives me 27. So it takes 3 of them multiplied together to get to 27.
Oh, you're looking at the denominator or something.
Yeah. Right. 27 to the 1/3, and you multiply it by itself 3 times. Remember, when you multiply the same basis, you add them. So 1/3 plus another third plus another third. I have 3/3. I have one whole.
So if it was a fourth, it'd be 4 times. If it was
Yeah.
a fourth, it'd be 5 times.
Exactly.
Oh,
So this is what number multiplied by itself 3 times equals 27. Right? And it's the same thing as the cube root.
so it's always 1, if it's 1 over something, right?
Yes, it's always one. It's always going to be, yeah. It's always going to be like that. It's always going to be the 1/3 or 1/2. That's what we're talking. We're looking at the square root and the square root and cube root numbers. So this is the same thing as a cube root. So 27 to the 1/3 is the same thing as the cube root of 27. We call these things roots. This is the cube root. That's the square root. This is the 5th root, because 27 to the 1/5 to the 5th power gives you 27.
But if it was like 2/5, then what would you do?
Oh, well then, that's the square of the 5th root.
Or we're not going to be dealing with that in this class.
No.
Oh, okay.
We'll do a couple of squares we'll do a couple of squares of 3s and 2s a little bit.
Oh, here, like
But
that.
yeah, so
3,
here's
2.
one. So
Okay.
here, this is not equal to this. No, that's in it. So this is 36 to the 3/2. You can write it by the exponent rules. You can write it as 36 to the 1/2 to the 3rd.
Mm,
So see that?
yeah. That's
What's 36 to the 1/2? It's 36 to the 1/2 power.
it's 1.
What multiplied by itself
Oh,
gives you 36?
36.
What multiplied by itself gives me 36?
One.
36 times 36 is not 36.
Oh, 1.
What multiplied by itself gives me 36?
Oh, 6.
6. So remember, 36 to the 1/2 power is the same thing as the square root of 36. So let's be extra sure about this. (16 to the 1/2 power) is the same thing as the square root of 16. 27 to the 1/3 power is the same thing as what? 1/3? Do you folks remember how to rewrite this as a radical?
Oh, cube root 27.
Yep, this guy is the one that goes inside of here. Right, this goes inside of there. So remember this part? We did a bunch of these. Just a reminder. Right? This one is the invisible one that goes inside of here. Remember that that has an invisible 2 in it. So back to this part here. This is really, if you want to rewrite it as a radical, if that makes you, I think people might be more familiar with that, right? Think of it like this. So it's square root of 36. Square root of 36, somebody else, not Eric.
6.
6. 6 to the third.
Hey,
So
6 times 6 is 36, that's not, 3, what?
that's the square root.
Oh, square root, oh.
Square root, and then we raise it to the third power.
Oh,
So here, you found it, and I can't remove the parentheses yet because it's being raised to a power. So what's 6 to the third power? Left side of your calculator, so you'll get 216. Yeah, don't worry about it. It's okay. These next ones, though, we should take a look at. Rewrite this as 8 to the something. Fill in this part here and that part there. Get an idea?
we didn't get this handout, right? We're just writing this on scratch.
Right,
paper?
yeah.
Oh, okay.
It's not on your handout, this is not on your homework,
Okay.
I don't think.
No.
We're just.
So, what, or you know what, we can rewrite it as a radical if you want. I'll let you, we can rewrite it as a radical. So rewrite it as a radical, but I want the parentheses, I want this part to be on top. And this part inside. What goes on the outside? What's the number on the outside?
3.
Brian?
3.
Oh yeah, I messed that one up. Okay, so that's not going to help us because I don't know what the square root of 8 is. So that doesn't help me. So I'm gonna pull the 3 on the inside. So one of the 3 is on the outside like this, or on the inside. You can do it either way. You can do the third root first. I'm sorry, the third root first. The square root first, or you can do the raise to the third power first. So we need to find 8 to the third power. Means I need to bust out my calculator.
So these are the same, right?
Yep, those are the
These
same.
Okay.
8 raised to the third power is 512. Oh man. Okay, I screwed up. This is supposed to be to the 2/3, not to the 3/2.
Oh.
All those are to the wrong ones. Darn it. So writing this is fine, but we can't solve it by hand. That's the problem. So let me fix that, so we can do ones that we can actually solve by hand.
So we're making it 2/3 instead of 3/2. So.
Yeah. Let me do this. Let's do that here. I want 2/3 also. Okay. For that. So this one, we can write it as, so everybody write this part. Like that, and fill in what goes in here and here with the new one. Fill in that and that. Okay. Natalia, what'd you get for this little with the inside part here?
Cube.
3? Yep. And David, what'd you get for this outside part up here? Up here. What goes up here? 2. Perfect. Great. So we all know the cube root of 8. What's the cube root of 8?
2.
What number multiplied by itself 3 times gives me 8?
2.
2. It's in parentheses. Is there something acting on it? Is there something multiplied in front of it or raised to a power?
Yeah.
Yes, so we can't take away the parentheses yet. So what's 2 to the second power?
4.
4. Done.
What's that?
That's it.
Okay, so you have to do the first square root first before.
The cube root, yeah.
The cube
so
root first,
with these
right?
ones, when you have a cube root, you want to do the cube root first because it's just easier, right? 2 is a lot easier to work with than 64.
Right.
And that's not as bad, but it gets worse down here. So that's why it's easier. When there's simple ones like that where you can take the cube root or the square root, it's easier just to get that out of the way, and then you have a smaller number to work with.
So does that hold true with the order of operations, I guess? We're always going to do it like that? Take
You can do either one.
Oh, either way, it goes.
It depends. It's up to
Okay.
you.
Okay.
Whether you do the 3 part first or the square part first.
Okay.
So with if the cube root exists, it's easier to do that one first because then you have a small number to work with. Then I have 2 to work with. 2 to the second, piece of cake,
Mhm.
right? All right, 64 to the negative 1/3. What's up with the negative exponent?
You have to flip it or sit.
You move it to the bottom. Yeah, you flip it to the bottom side, to the opposite side.
3-1.
So I'm going to flip it to the opposite side and make it what? And write what this should be instead.
Oh, this is Which is 64.
Okay. 64 to the what?
1/3.
Positive 1/3. So what? So this means we'll multiply by itself 3 times, gives me 64.
Oh, you flip the whole thing.
We flip it this way. Yep.
Oh, I just flipped the fraction. You flipped the.
No. You move it to the opposite side. Okay, so 64 to the 1/3. Do you folks want to put it like that first? Do you feel better about that, or do you want to just leave it like this and just? Either one's okay. But what multiplied by itself? What's 64 to the 1/3? What multiplied by itself 3 times gives me 64?
4.
4. Is everybody all right, that part? Okay, good. And then this next one, we're going to do them in pieces. So we're going to do the 8 on top. 27 to the 2/3. So do the same thing you did with the 8 to the 2/3 above. Do that down here. So same thing you did to above. Do the top part separate. Do the bottom part separate. Just do them separately.
Put that up past to both the top and the bottom.
So now I'm going to do this. Do this. Fill in something here. Fill in something here. Fill in something here. parentheses around it if you want, maybe that might be easier. All those pieces, and then simplify it, right? Okay, raise your hand when you have those 6 circles filled in.
27.
Give me a little wave when you have those 6 circles filled in. You got it? You got it? Dave, do you have those 6 circles filled in yet? Check your answers and with Ryan behind you, or Natalia. Either
Just
one.
like this?
Well, all of that.
Yep, where's the print?
Great. All right, so we have 8 here.
Oh.
We have the 3 here. We have the 2 there. I'll
Okay, gotcha.
27 cube root squared. Okay, so then next we just all we need to do is find what's the cube root of 8?
2.
2. Great. So it'll be 2 to the 2nd. What's the cube root of 27?
3.
3 squared. So 2 squared is what?
4.
4. What's 3 squared? 9. Done. All right. Now I want to get into some of these. So everyone's going to need a piece of paper to write these down. I guess I should have. In the future, I'll probably try to get these written out. So I may need a spare piece. So just plain white paper. I may need one. You have one. You have that. That book is better.
Oh, you want to start do all these?
You need a sheet. Okay. I'm going to do them together. We're going to do these together.
Oh.
All right. So here's the deal with these ones. They break out of jail. So think of this as jail. I'm going to make this into a 2. Make that a 2. Okay. So the first one is, let's take care of this 48 thing. Kind of the easiest way to simplify this is, how do I factor 48? So here I just want to factor 48. Okay, 48. So numbers, when you have numbers, you want to factor them. The easiest way, how do you tell if something is divisible by 2?
Even number.
It's an even number. How do you tell if something is divisible by 5?
Multiple 5.
I mean, there's something's multiple of 5. What do we know about it?
A 5 or a 0?
Ends in a 5 or a 0, right? 5, 10, 15, 20, 25, 30. Ends in a 5 or a 0. If you want to know something is a multiple of 3,
Would you add them up and then?
yeah, did I talk to you guys about that already or not yet? No?
No.
What did you say again?
You add the digits up and then divide by 3 or something?
This is divisible by 3. How do I know? Because 2 plus 3 plus 4 is 9. Is 9 divisible by 3?
Mm-hmm.
Then this is divisible by 3, for sure, 100%. It's divisible by 3 if you add, what do you call it, the digits